Welcome to second day. Yesterday I gave what is Python, why Python is so important in today's scenario. And also I gave some IDEs that are useful, that are actually used by many people with respect to Python. And here I'm going to use two IDEs. One, as I told you, one I'm going to use is IDLE. So IDLE, if you want IDLE, you have to download Python. So if you want to download, if you download Python, automatically this is available. So just go to Google and say download Python download. So it will take you to the Python website, Python.org. From here you can download the latest version. Download Python 3.9.5, which is the one I have with me. If you download, IDLE is automatically available. So if you download and install, IDLE is automatically available. If you want to use IDLE, just click here IDLE, then click here IDLE, you will get IDLE. So you will get IDLE and you can enter into this environment. So that is one IDE I'm going to use. It is very simple IDE. It is the default IDE that is available along with core Python, which you install in your system. And it is with core Python library. If you want some third-party libraries, you have to install them separately. Okay, I'll give you later how to install the third-party libraries if you are using this particular one. So this is ideally this is I'll be using for some only for some demos. For other demos, as I told you, Google Colab I am going to use. Google Colab, if you want to use, just you should have Google account and internet. And if you have some Gmail account or Google account, if you log into will allow you to get third-party packages will be readily available. That's what I told you yesterday. So this is about the IDEs I'm going to use, and the IDEs, the two IDEs I'm going to use. One is IDLE, which you have to install, to which you have to install Python, and it is the default IDE for Python. And second one is Google Colab. For that, you require only internet connection and Google account. So you need not install anything. You can start using it. So that is the IDEs which I'm going to use. Next thing, what we have to know is library. So today we'll start learning about the library. What is library and how to use the library. Okay, library is the important thing for any language, especially for languages like Python. Library is more important. If you take C language, the library is very limited, and mostly we do it from scratch. So when you take library, so when you have a problem, problem here means the one for which you want to develop a software. So the problem normally is big, and we will be solving it by dividing into parts. So I'll be dividing into parts, and each part I'll take it as subtask, or this I can also call it as task, and each one I can call it as subtask. Subtask 1, subtask 2, subtask 3, and so on. Now, normally what we do as part of solution for any task or subtask is we write the program. Program means we write the code, some code, a set of statement. Now, for any subtask, suppose if there is a subtask, if already there is a solution available, ready-made solution is there. So this is library. So for any task, smaller or bigger, if there is already a ready-made solution is there, that is library. So library is collection of ready-made solutions for different tasks. So, or you can say in general, library is collection of ready-made facilities. So most of the times we'll be using those facilities. Now I have a task, subtask, like suppose if I want to find matrix function, I want to get. So in two ways. Suppose if there is already a ready-made solution, I can use that, or I can write my code from scratch. From scratch means everything I'll be writing. So there are two ways. One way is I can use the ready-made solution. Suppose if it is available, this is one way. Second way is I can write it from scratch. Now, even if you are a good programmer, it is always recommended to go with ready-made solution because of several reasons. When you take from scratch, the first problem is you have to spend time. So the first problem is time to build it, because everything you have to write, time to build, time to write code. So you have to spend some time to write the code. That is one thing, one disadvantage. You have to spend time. Second thing is, if there is a very possibility that you are writing the code, you are a good programmer. You are a good programmer, you are writing the code, but still there is a possibility that you will be doing mistakes. So there is a problem of errors that that will be there in the code, and sometimes those errors are very difficult to find. So you will be thinking that everything is perfect, but there will be surely errors. So these two problems if you will face when you write some code from scratch, even if you are a very, very good programmer. But when it is a ready-made solution, it is already there. It is proved. Because when you take Python library, it is used heavily. There are so many people using, and if there is an error, it would have been revealed and it would have been corrected. So there is a very, very, very less possibility that there will be error in it. Second thing is, it is readily available. It is readily available. I have to just use it. So time will be time to write code is nothing, because I have to just use it. Second thing is, there is every possibility, there is no possibility of error if it is a library function. And third thing is, because it is written by experts, and they'll use the expert. It is written by expert, and they will use the resources to the maximum possible efficiency. Resources means the CPU, the memory. By keeping all those considerations by keeping all those into consideration, they develop the library. So the library that is already there is very efficient, very efficient. I'll prove. I'll give you one demo today. Why library is so efficient. Even if the solution, even if the task is a simple task, and even if the task is complex task. So when it is library, the advantage of library is first thing is no time. You need not spend any time. It is ready. Just use it. So you need not spend separate time to give a solution. Solution is readily available. There is no possibility of error. We can say there is no possibility, because Python library is used by so many people, and if there is error, surely it would have been revealed and it would have been corrected. So I can say it is no possibility of error. Third one is it utilizes, the library utilizes the resources. This is very important thing. I may write a code, but I'm not utilizing, because unless you are very good at hardware, how processor works, how memory works, how cache works. If you are not good at those things, you will be writing very normal code. But there are some experts who can do some low-level programming. They can utilize those resources to the maximum extent. So it utilizes the resources to the maximum possible extent. Resources to the maximum possible extent. Resources means here processor, memory, the cache, all those things, maximum possible extent. So it is the best code. It is best code, not only in terms of for most of the tasks, there is already a solution in Python. So our uh, what we but possible extent. So best possible extent. So the best code and efficient code is available, will be available in the library. So when there is a task and if you have to develop a solution for that, and if there is already a solution available in the library, blindly go for it because of these three reasons which I told you. Instead of writing from instead of writing your own code from scratch. So always, even if you are very good programmer, you are very confident about your abilities in writing code, but still go for library, because library utilizes the resources to the maximum possible extent. So before I proceed with the how the Python library is present, I want to give a small demo to show you how the library is efficient. Even if you don't understand the code much in this case, don't worry here, because my intention is to show you how powerful the library is. So here I told you the Google, I'm using Google Colab here. And I told you Google Colab can mix the documentation with code. So I want to write this. This is I can say here Python programming. So we are learning Python programming. It is the, when I use one hash, it is the header one. So when I use one hash here, when I type one hash, it is somewhat bigger header. If I use two hashes, it is somewhat smaller. It will come under the bigger header. I'll say day one. So we have yesterday we have written this. So this is day one. Now day one will come under that because it is second header, second level header. This is top level header. When I use hash here, it is top level header, single hash, and you can manage this easily. So if you want to hide some code, because you will be writing a lot of code and you want to view only a part, you can hide the remaining code with the help of here. There will be, say, day one, day two, and so on will be available here. But here we have only day one. So day one, we have written something here. Next, I'll write day two with one more header. So day two, this is second level header. Day wise, I'm keeping every day I'm keeping second level header. So now if you take here this second level header, so it comes under here. You can see it is under this day one. Day two will be there, and you can, because within day one there are some cells, within day two I can have some cells, and this is total control because it is top level header. So it is very easy to manage the code, but initially you may feel difficult. You can easily do it because it is very simple and very useful one. So in day two, what I want to give is I want to give first the power of library, that I'll keep third level header. Only three levels header we can have. So power of library. So I have not given, I have just given what is library, but I have not given the different libraries that are there in Python. I'll give you next, but I want to give you a demo for this. So I'll write a simple code. You may be aware of that code. Like what I want to write is, I want to write code for so I want to write code for factorial. You know factorial, no? Many you may know factorial. So factorial of n is when I take factorial of n is you can say n into n minus 1 into n minus 2 into and so on up to 1. Or normally in programming we do it in reverse, say 1 into 2 into and so on into n minus 1 into n minus 2. This is n minus n. So to find the factorial. See here, the code what is required is very simple. If you are already know some programming language, you might have written the code. So I want to write this code first. I have not given any components of Python to write the code, but still I want to show you this code. So here my because I want to show you the power of the library. So what I'll do is I can also have some bold text. So factorial finding fact with code writing for factorial. So make it starting star and double star. Uh, I think the with uh, okay, again, there was a network issue. Now I want to have a given about this factorial. Okay, factorial I was giving. I want to find factorial of a number using my own code. So I'm using the Google Colab. Here I'm mixing code with documentation. That's what I told you, the power of Google Colab. So I'm saying day one, day two, and power of library. Then I have written a text in bold form, which gives the questions for which I'm solving. So I'll take a code here. Even if you don't follow, it does not matter. Just I want to show you how powerful the library is. So here for I in range 1 to n, I'll read n value, or n, I'll say 5. So I'll say fact So are you able to see the screen now? Okay, okay. So here I'm writing the code for factorial. Even if you don't follow the code, it does not matter. If you are very new to programming, don't bother. Just we'll be learning all these things, but just see what is happening here. If you are new, so I'm finding the factorial. I'll print the factorial. So this is one code. So it is connecting with the server. Here it is showing the status, and it is connecting with the cloud server, and now it is connected, and it executes and it shows the result. So it is showing factorial of 5 is here. There is small mistake in code. So factorial of 5 is 120. So we'll get 120 here now. So 120. So this is how we have to find the factorial. This is very simple logic. I know that the logic is simple. I am writing. But if I want to find factorial of very big number, I don't want to print, just I want to find factorial. Because here our aim is not result, our aim is to how fast the code is going to be executed. So it takes some time, and it has found, and I'm not printing because I'll print it for this. It does not matter. Fact, I'll print it. Now it is giving very big number because factorial of 100 is very big number. I'll talk about this big numbers now. Next, here this solution has already this task has already a solution in the library. Okay, here now what I'll do is code which uses library. So first I'll check whether both results are same or not. Then we'll see the other things. So I'll now just write a code. Don't bother about the code. Just I'm repeatedly telling you. So just I want to show you how powerful the library is. So fact equals to math dot factorial. There is already a solution n. So I'll print this. Print fact. So it is finding the result. So you are getting same result. So this is my own code I've written. This is the library code I've used. So I'm writing some loop. I'm multiplying. I'm taking a range. This is my own code I'm writing from scratch. So I'm finding factorial of some 100, which results in very huge number. In Python, I can find factorial of 1000 and even bigger also. Now, I want to see how much time this code takes and how much time the library code takes. So I'll remove print because print is IO. IO generally should not be involved in finding time because IO depends upon the device. So I'm removing IO, but just I'm performing the main job. Then I'm finding the time. So to find the time in Google Colab, I have percentage time it. So it will give you the best possible time by considering several attempts, and it finds the best out of best thing. So you will know that. So I'll execute this. So it has taken to execute this, it has taken 6.89 microseconds, and the best 5, it has done this 10,000 times. Best 5 is taking 6.89 microseconds to find factorial of some number. Now I can find, suppose if I take 1000, it will take more time. Factorial of 1000 also we can find. So it is taking 230 microseconds because now I have increased 10 times. So the time taken to find factorial of 1000, the best possible time with whatever code I have written is 230 microseconds. Now the same thing I'll do it with library. So n value is now 1000. So you can check here also you'll get n value as 1000. So I'll say print n. So n sorry, this is executed n value 1, n value 1000. So I'll print this again. This. Okay, I'll take n value here. N value 1000. Okay, so I'm finding factorial n. Now I'll say percentage time it. So it will find a factorial of 1000 using the library. So if you take this, it is taking 971 nanoseconds. This is taking 227 microseconds. So this is nanoseconds is 10 power minus 9, microseconds is 10 power minus 6. So it is actually doing 7 times faster, if you use the library. I'll go for bigger number so that I'll go for 1000 here. So I'll go for not 1000, 10,000. So it is taking 20.6 microseconds, sorry, milliseconds. Now I'll do it for this. We'll see how much time it. So it is taking 2.74 milliseconds. Now you can find the difference. So if you divide 20 here, I'll do that. 20 print, or I can directly say 20.6 divided by 2.74. So it is 7.5 times faster. The library code, whatever is there, it is executing this, it is giving the same solution with 7.5 times faster than the code which I have written from scratch. So this is why I told you that for any task, if there is a solution readily available, blindly go for it, because see, this code is simple. There is nothing to improve the code, but the utilization of resources requires some low-level programming, and library is written with low-level programming. I'll come to the library next. So library is written efficiently. So the best possible way it is written. So if I take, I'm finding factorial of 10,000 in 20.6 milliseconds, and here I'm finding same 10,000 in 2.74 milliseconds. I'm finding in 2.74 milliseconds. So that's why I told you the library is always the best thing in program in Python. Not only in Python, everywhere it is. Library usage is always better. So I'm repeatedly stressing that always go for library solution if it is already available. Here I'm using the library called factorial. It is already there in Python, so I'm using it. Here this is my own code. So this code uses library. I'm adding some comment here. Here I'm finding factorial of a number with code written from scratch. So I'm writing my own code, which is there is nothing efficiency here. Because the code for finding factorial is very simple. Keep on multiply the numbers from 1 to that number, I'll get factorial. But utilization of the resources is very important. Low level programming that is done in the library efficiently. So that is one point to note with respect to the library. So I've given the speed with which the library is executed. So that is shown clearly in execution time. Okay, next I'll give you the library of Python, how it will be. So you know what is library now, what are the benefits of the library, and we have also seen a demo. Here, the point to note is the speed. That's all. Remaining things, ignore it because you may not be knowing programming. If you are new to programming, you may not be knowing anything here. But if you are already programmer, you may be following this. But even if you don't follow, it does not matter. The important thing is here this the speed with which the library code is executed. That is the important thing. So next we'll see the library of Python. So library of Python we're going to see. So as I already told you that library is a collection of ready-made facilities. Now the library, when I take the library of Python. So if I take the library of Python, It is very huge library, so it will be available in different forms. So first part of the library is built-in functions. So there is built-in functions. What is that? I'm going to give built-in functions. This is one library, one part of the library. The second part of the library is built-in modules. This is second part of the library. And third part of the library is third-party modules. Third-party modules. This is one more type of the library. And fourth one is any .py file. So these are the different library components we can have. This is Python library. So Python library is a collection of ready-made solutions, and they are available in the form of built-in functions. They are available in the form of built-in modules. They are available in the form of third-party modules. You can say third-party modules. Then finally, there is fourth one, which is any py file. Okay, I'll give each one separately. So when you take the first one, built-in functions. So built-in functions is one part of the library. Then built-in modules. Then third-party modules. .py file I will give you later. Third-party modules. So the first thing what I want to give you is in the library, when you take the built-in functions, the first point is built-in functions and built-in modules are available along with the core Python what you install. Core Python. So they are available readily with core Python. Available with core Python. Available with core Python. So both things are same, available with core Python. So if you install Python from this website, whatever I told you, built-in functions and built-in modules are readily available. So that is one thing you have to note. Now, when I take this third-party module, needs to be installed separately. Needs to be installed separately. Needs to be installed separately. And one more thing is these are more generic, means they are useful for almost all the people. They are specific to the application. Specific to the application. Like for example, data science, there will be third-party module I have to install separately. Now, whatever I get from core Python, it is not application specific. They are useful generally for any application. So that is generic. So useful for all kinds of applications. Useful for all kinds of applications generally. Now, when I take this third-party library specific to the domain, means if it is data science, there will be pandas, there will be NumPy. If it is blockchain, there is a different thing. If it is graphical data visualization, different library. So it is domain specific. They are not useful in common. General for all applications, they are not useful. They are useful specific to domain. So if you are working in blockchain, install the third-party libraries related with blockchain. If you are working in data science, install the third-party libraries related with data science. That's how it works. Okay. So they are specific to the domain. You have to install them separately, but these are available bundled with, these are bundled with core Python. So available with core Python means they are bundled with core Python, main language, bundled with core Python. Bundle with core Python. So they come along with Python. This will not come along Python because they are not common. They are specific to the domain. They are very generic or common, so useful to all. So they are bundled with Python. They are not useful to all. They are specific to the domain. So they are not bundled as part of core Python. You have to install them separately. But data science related packages are readily available in Google Colab. So only data science related packages like pandas, numpys, then even Seaborn, all those are readily available in Google Colab. Google Colab is a different thing, but in general, I'm speaking. So this is one difference between built-in functions modules and third-party modules. So the next thing is, the next thing what I want to give you is, this is main difference. Now we'll see the difference between built-in functions and built-in modules. Built-in functions and built-in modules. So if I take this here, if I continue. Now here, the third point is you can use them directly, What is that? I'll give you. Here, you have to import, put extra effort, import package, then use. So that is one difference. Like when I take this here, I'm using factorial. I cannot use factorial directly. I have to import something. What is that import? What is that package? Don't worry. Just remember that built-in modules requires extra effort to use it. I cannot straight away use it. It is not direct usage. But if I take built-in functions, I can use directly. For example, I'm using factorial, which is part of some math. First, I have to import, then use it. Now, suppose if I take, there is a built-in function, I can say min 10, 25, 15, 6, 23. Suppose if I take this, which will find minimum, so I can use it directly. So that is a built-in function. Even I'm using something here. Am I using any other thing? Range, it is a built-in function. Range is a built-in function. So min is a built-in function. So here, what you should know at this stage is built-in function can be used directly, but in case of built-in modules, you have to put extra effort. You should know where it is available, in what bundle it is available. You have to import that particular bundle, then use it. So the library core library, which is bundled with Python, will also have small bundles inside it. So it is like this. I can write it this way. So when I take third-party libraries, I have not considering now because I have given what is third-party libraries. Suppose if this is a core library, means the library which comes along with Python. So there is a bundle math is there, bundle string is there. Then there are direct usage. Min is I can use directly. Input I can use directly. Sorted I can use directly. Now these are built-in modules. So here I can use this directly. I can say min because this is a built-in function. Now if I want to use something inside this bundle, first I should know what is there in that bundle. I had to use that bundle in the program like import math. Then I can use math.factorial. So I should put extra effort because it is not directly available, it is inside the bundle. Now it is openly available, I can use directly. So that is the difference between built-in function and built-in modules. And this is one thing, it is directly available. Here you have to put extra effort. I'll give the next point and then yeah, it is this one. So I'll give the next point related with this. The next point is here, this is written in C. So the built-in functions are written in C. So they are faster. These are also mixed. Means some written in C, some in Python. So, but they are efficient, as I told you, because when I take factorial, it is actually part of the built-in module. So it is mixed, some written in C, some written in Python, but built-in functions, they're all written in C. So when I take this, all are very efficient because the library itself is efficient. Just one more difference is the built-in functions are written in C and built-in modules are mixed, some written in C, some in Python, but built-in functions are written in C. Now, when I take these built-in functions, I'll show you the built-in functions here. Or if I have any slide, okay, the built-in functions, because we are going to use them, built-in functions in Python. So built-in functions in Python. So I'll go for this Python documentation. So these are built-in functions. They're all, I can use them straight away. When I have Python, I can use them straight away. So like there is a min here somewhere. There is a min present. There is a sorted present. Where is sorted? Should be somewhere. Sorted is there. So there is all is present. Then input is one more which we use. Length is one more. So this I can use straight away. I can use these functions straight away, and we'll be learning. I'll be giving some which are very common. We'll be discussing about them whenever it is required. So these are built-in functions. So there are several built-in functions here in Python, so you can use them straight away. And there are so many built-in modules. We'll be learning about those modules. Here you should know what is the difference between built-in function and built-in module. That is given already. What is the difference between built-in function and built-in module? And third-party module, if you install, then it becomes like a built-in module. You can use it. And the last part of the library is you can use any Python program. You have already written some Python program .py file. You have already written some Python program which is .py file. I can use this as a library. So I'll be showing you later because it is slightly advanced. So how to build our own modules, how to write, how to use a .py file as library. So you can take any Python program, I can and use it as a library. So these are the libraries that are there in Python. So this is how the library will be present. And so library, there are 4 collections here, types of components in library. One is built-in function, then built-in modules, then third-party modules, and any py file. Now, when you take the difference between these 2 third-party modules and built-in functions and built-in modules, they are bundled with core Python. So they are readily available, and also they are generic, useful for all kinds of applications. These are specific to the domain like data science or blockchain or any other thing like web related. So network related, database related, they are specific to that domain, and we have to import that package and use it. And that is the difference between built-in functions and built-in modules. Next, when you take the built-in function, this built-in things and third-party modules. Now, if you take the difference between built-in function and built-in modules, built-in functions you can use directly here. They are part of some bundle. You have to take that bundle and use it. You cannot use it directly. These are openly available. You can use them. And the built-in functions are written in C, but built-in modules are written in C, Python, and other languages. So that is one thing I want to give you. So that is about the library. So will be this is not complete related with the library. Just I've given the overall picture of the library, but as part of Python course, will be learning the functions, several functions, built-in functions. What is the task solution or task associated with each built-in function, and what are the different modules, built-in modules available. So we'll be learning as part of the course all these things, and we are not going to learn any third-party modules, but we are learning completely this built-in the library that are there that is there with core Python. Because I told you this course is not application oriented, so third-party modules are application oriented, specific to domain. As part of the course, we are not going to learn those things. But example for third-party modules is Pandas. Pandas is a third-party module. NumPy. There are so many available. Then Seaborn is third-party module. There are so many, but we are not going to learn as part of the course. So that is the overall picture of the library. What are the different things that are there in Python library and how to use each one. We'll be learning each one as part of the course. The next thing what we should know is, I gave you that Python is a dynamic language. So Python is a dynamic language. That is one thing. What is the dynamic we are going to see first. So Python is dynamic. So here initially we'll be seeing the two dynamic concepts of Python. One is a dynamic data type, and second thing is dynamic size. So size, dynamic size. Now, before we see what is dynamic data type and what is dynamic size, normally in programming, there are two things related with dynamic. One is dynamic, another one is static. One is dynamic, another one is static. So when you take the program, you will be writing source code. You will be writing code, but you know that source code is uses, suppose if it is Python.py, C it is .c, Java.java, and C++.cpp. Like that, there are source codes. You will be writing the code, but this code is in English form, English text. So it is not readily executable. So what you have to do is when you write the source code, because it is in English form, but computer understands only binary form, zeros and ones. Computer understands zeros and ones, only zeros and ones. This is called as machine code, machine language. So the language what machine understands is zeros and ones, but the language what we understand is English. So Python is in English like code, C is the English like code, but this is not understandable to Python. Now the source code, before it has to be before it is executed, source code is converted into machine code. Source code is converted into machine code, then it is executed. even in between after conversion execution, there are some stages. Don't worry about those stages. We are not going to much bother about it. Now, when anything you are taking a decision here during this stage, if you are taking some decision or activity during execution styles, it is dynamic. When anything if you are doing before this execution, is static. So while you write the code, you are taking some decisions. While executing, you are taking some activities or decisions. Any actions or decisions, if you are doing it during execution, it is dynamic. Any action or decision that is taken before execution is static. Because whatever decision or action that is taken before execution, this cannot be changed. It remains same. Cannot be changed. It remains same. So this is the difference between static and dynamic. So when I take Java is statically typed language, the size is static. When I take C is statically typed language, the size is static. But whereas the Python, if you take, it is dynamically typed, dynamic data type, dynamic size. That means the type of the data is decided, during execution, and size of the data is decided during execution. But in Java and C, the type of the data is decided before execution, and size of the data is decided before execution. So at this stage, just if you know what is static, what is dynamic, it is enough. So when I write a program, that program is source code. I'll be writing, editing, then I'm doing some conversion. Conversion will be done with compilation or interpreter. Then I'll convert it into machine code, then I'll execute. So if I'm doing some decision or action, some kind of decisions or action during execution, it is dynamic. If it is taken before execution, it is static. So if you know what is the difference between static and dynamic, at this stage it is enough. Types I'm going to give you. So, Python is dynamically typed and size is dynamic. C is statically typed and Java is statically typed. The size is static in C and Java. Okay. So that is actually one important thing we should know before we start learning Python. So we have not started Python, but we are learning some concepts which are required to start learning a language. Like library is required. We have seen what is a library, but I have not discussed anything in the library. But what is library, we know now, we have seen. Now, two things we should know: what is dynamic and what is static. So that we have seen now. Now we'll see what is type, data type. Now we'll see data type. Now, when you take the software development, there are two things. One is data, another is the program. Now, data is more important than any other thing. Data is very important, more important. Nowadays, data they are selling. It is very important than program. So getting data is very difficult and it is actually costly. So there are two things, data and program. What program does is, it takes some data, it gives some data. So it takes data in raw form, it gives the data in useful form. So it takes the data in raw form, it will give the data in useful form. Like for example, one simple example what I can give here is, now student information I can take. student data I can take, like roll number, marks in each question of subject one, question two. I'm taking marks in each question, but this is the input I'm giving. But the result is I can say roll number, marks in subject one, marks in subject two, average marks, ranks, all these things which are useful format I'm giving. So in subject one, suppose if evaluator is giving marks for question one separately, like out of 10, 9, out of 10, 8, and here suppose there are three questions, question 3, 7. This will give total marks in that subject. For example, this is I'm not bothered about the marks, or I don't want to reveal those, but I'm giving the data in this form. So I'm giving the subject-wise marks and average marks in different subjects or rank of that student in that particular subject. So that is useful data. Now, when I take this data, there is a roll number, there is name, there is marks, there is average, there is so many things available. Now, if I take roll number, it may be something like 1, 2, 3, 4. Here, for example, I'm taking, it may be something like 20, A1, 5, 6, E65. It may be this form also. This is something like some text, like I may give some name like Virat. Then marks are something like 75. And I may take 63, suppose 93.5. So this is purely a number, numeric. This is alphanumeric. I'm mixing alphabets and digits. This is purely alphabets, alphabets. This is alphabetic data. This is integer, whole number. This is real number. So when I take the data which is required for the program or which is generated by the program, it's of different kinds. Some is whole number, some is purely digits, some is pure mix of numeric and alphabet, some is purely alphabets, some is whole number, some data is real number. So when I take this, these are actually the data types. This is considered as integer. This is considered as string. This is considered as integer. This is considered as real number. So based on what is carried in the data, so the type is decided. So when I take a real number, it is with a decimal precision, and whole number is without decimal precision. And there is alphabetic data, purely string. There is alphanumeric data, which is also considered as string. So overall, what you can decide is, conclude is, there is different kinds of information. Different kinds of information in data, in kinds of data. This kind is in programming language is type. So the kind of data is type. For example, integer is one type, string is another type, real number is another type. Suppose if you are taking true, false, it is Boolean type. Then suppose if I take 1 plus I10, this is complex number. So there are different types of data present. So every language will have data types. Every language will have data types to represent different kinds of information. So even Python has data type to represent different kinds of information. So if I take the data type, every language possesses a type, different data types to represent different kinds of information. Represent different kinds of information. So that is one thing. So data type is used to represent a kind of information. Now when you take this information representation, the information is represented inside the memory. Information is represented inside the memory. So suppose if I take memory, it is represented inside the memory. Now, suppose if I represent some marks, 95, these are the marks, but there will be some name to refer this value. There will be, this is identifier or name, identifier or name of the data item, identifier or name. So every value will have a name. Now in C, when I say in C, marks, I have to fix the data type, fix data type while I write the code, while I write program, because I'm deciding. So I'm saying marks is integer. So now during the entire course of the program, marks remains integer. So this is static, that is static data type. Later, once I start executing the program, now the type of the data is fixed to integer, it remains integer. But in Python, it is not like that. During execution, based on the value I give, suppose if I give 95, it is taken as integer. Now later I may change, and I may say this as 56.5. So this is a real number. Later I may change this value here, like suppose Virat. Then the data type is taken as string. The data type is taken as string. So these are actually the different types of data we have, different types of data we have. So when I take the different types of the data, now the type of the data is not fixed during writing the program. If I fix it during the writing the program, it is static. If I don't fix it and if it is keep on changing, when it is changing during execution, so it is dynamic. So this is one thing I want to give you. So the type in Python is dynamic. So the type in Python is dynamic. The different data types that are there in Python is there is integer data type present. So different types of data present, different types of data present in Python. So one is integer. Generally, we represent with the name int in Python. So there is a real number. This is we use in day-to-day life, and this is Python state representing integer. Real number in Python we call it as float. Then alphabetic or alphabetic data means which is represented with alphabet or alphanumeric data, means combination of these things. We call it as a string in Python. That is actually string or str. It is just str. That is another type of data present in Python. Then something like Boolean data, Boolean, and in Python it is called as bool. And normally the other languages does not contain complex numbers, so there is a complex data also, complex data. This is complex. So these are the basic data types that are there in Python. One is integer, another is float, which is used to represent real. Int is to represent whole numbers or integers. Float is used to represent numbers with decimal point. str is used to represent alphabetic and alphanumeric data. Bool is used to represent true or false values. And complex is used to represent complex numbers like 1 plus I 10, but in Python it is represented as, if it is 1 plus I 10, it is 10j to represent complex numbers. These are the basic data types that are there. For example, here I'll come back and execute this. Now I'll go for data types. So when I take data types, now I may take something like I may take A is 50. So now A is integer. So I can know the type here by saying type of A. So you can observe. So it is integer. But in C, so I'm assigning A to 50. So it is saying it is integer. Now later during execution, I'm still executing. I'll say A is 1.5. I'm at 1.4 or whatever it is. Then now I'm checking the type of the data. Now if I take, it is real number, float, it is keep on changing. But in C or Python, in C or Java, I cannot change it. So for example, suppose if I take A equals to, now I can write some text. So now I'll check what type of data it is. So it gives type A. Now if I take type A, so it is saying, so string, str data type, that is string. Now I can change it later. I can change it A equals to, suppose alphanumeric. Suppose some roll number I'm taking 20A 5 or A. Suppose if I take capital 5 here 5, then A 2 3 4. Suppose this is alphanumeric, and it is still called as it is still string data type. So numeric, alphabetic and alphanumeric is treated as string data type. So it is string. Now suppose if I take A equals to true, A equals to true, then check the type. So print type of A. So now it is Boolean type. Suppose if I take A equals to 1 plus 2.5J, now print type of A. So these are the basic types that are there. There are other user defined types. So these are the different types. One is integer, another is float, another is string, there is bool. These are the types that are there. Now what here to know is the type of the data is not fixed. Now, for example, suppose if I take C language, I'll give you a demo, simple demo in C, how it will be, how different it is from Python. So in C, if I want some, don't bother about the syntax, whatever format I'm writing, the structure, it don't bother. It is C, I have to write like this. Suppose if I take, now if I take A equals to 10, it will not accept. It will give error because we have to fix the data type while I write the code. I'm writing the code. I have to fix the data type. Suppose I'll say test 1. So it is giving A was not declared in the scope. We have to mention the type. So if I mention int, so it will accept. It will accept. So I'm not doing anything. So it is taking the type. Now the latter, suppose if I try to assign some string A equals to hello, it will not allow because this is the type is fixed. I'm saying A should be integer. When I'm saying A should be integer, while I write the code, during execution, I'm giving a value to A, so that cannot be changed. So it is saying error, invalid conversion from a constant char to integer. So this is a set of characters. I cannot store it in integer. So one thing that is what you should know here is the data types. Type of a variable means the name whatever we give to a value. Here type of a variable or data item is nothing but, so this is the one. So what I am saying here is in C I am saying a equals to 10. So when I say a equals to 10, some memory is allotted to a, 10 is stored. Now this is fixed integer. I am deciding before execution and it remains same. I cannot change later, cannot change. If I try to change, it will not allow, C will not allow. But in Python, what I am saying, initially I am saying 10, then it says, okay, this is integer. Python understands that it is integer. Later, I'm changing this to 1.23. Now the Python understands that it is a float. Later, I'll change it to something like this. Now Python understands that it is str. Later, I'm saying it is true. Python understands that it is bool. So the type of the data for data of an item variable is not fixed during before execution, and it is decided during execution. That's why the type of Python data type is dynamic, and Python is dynamically typed language. In case of C and Java, it is static. It is static because the type is decided before execution. Type is decided before execution. Here type is decided during execution. Type is decided during execution. Anything that you decide, I told you, anything decision you take or action you take during execution is dynamic. Any action you are saying the type of this is integer before you execute. So this is static. So that's why C and Java are statically typed languages and Python is dynamically typed language. So this is one thing you should know. So I have shown you in C, you cannot change the type once you fix it. But in Python, we have seen same data item. I'm changing. Initially, I'm giving 50. Okay, it says, okay, there is no problem for me. A is now integer. Later, I'm saying 1.4 during execution. These are all during execution, or I can mix all of them into one. I can mix all of them into one. And I think, okay. I think we can combine into one here directly. So I'll merge all of them. Now I'm executing. So during execution, now it is keep on changing. So I'm deciding that A is integer during execution. Later, I'm deciding that it is float. See how it is changing. Initially, it is integer when it is 50. Later, it is float because I'm assigning. This kind of thing is not possible in Java or C. So that's why they are statically typed languages. But Python is dynamically typed. So the type of data item is decided during execution based on the value what we give. I'm giving 50, so it is deciding that it is integer. I'm giving 1.4, it is deciding that it is float. Then I'm giving string, it is deciding that it is str. So this is how the dynamic data type is actually present in Python. That's why Python is dynamically typed language. So